Hello and welcome. I'm Gene, a genius programmer. Gene, genius, kind of genius idea, don't you think? This is my new channel. I'm very excited about it and I cannot wait to tell you everything about it. But first, let me tell you something, and that may sound really crazy, but that's not the first time I'm having this feeling. I feel like I'm being watched right now. Okay, I'm back. It looks like they implemented some changes in Matrix. I really like this bright office. A little bit flat though. Can we... Oh, much better. I love it. Okay, back to the topic. The reason behind creating this channel was to talk about algorithms. Hence the name, Algorithmics, duh. But I'd like to look at it from a little different perspective. There are tons of videos on YouTube about algorithms, all different levels. Everybody and their brother is talking about Fibonacci, factorial, reversing strings, you name it. I think you can find it all. Is there any specific reason why I want to talk about it? Glad you asked. Yes, everything has a flip side. Even a flip side has a flip side. That was kind of deep. Anyways, let me explain. We learn to program studying algorithms. I've done it and I'm still doing it because I like solving puzzles. I like keeping my brain working. Some people solve crosswords, others like Sudoku, for example, or playing chess. I used to play chess, but as a kid I preferred playing Mancala, which I knew as Kalah. And I loved solitaire. Well, I mean playing cards, of course. I never had a diamond solitaire, which would be nice, by the way. Many companies give coding assessments which contain algorithms. No judgment here. I understand they need to have a way to figure out how much candidates know. Can they think algorithmically? The problem comes when we start writing our code the same way we write algorithms. I will take a liberty to say that most of us have done that. I certainly have. What do you think if a librarian who is passionate about crosswords will organize bookshelves in the library using crossword approach? Kind of cool idea, but then every person would have to solve the crossword if they need to find a book. Crosswords, in my humble but accurate opinion, make a very poor search algorithms. This may sound ridiculous, but I can see something similar to that almost every time when I need to go and modify an existing legacy code. That may look like there was an explosion of a spaghetti factory. Bits and pieces are everywhere, and if I touch something, then some other functionality may stop working on the other side of the universe. Yeah, I know that's a reason why we have unit tests. But isn't that fascinating when you touch one small function and half of your well-crafted hundreds of unit tests turn red, about half an hour before you're supposed to push it into production? I know that has never happened to you, alright, I'm just making a rhetoric statement based on my own experience. But today I'd like to illustrate this using a very simple algorithm that's a famous FizzBuzz. No, I'm not trying to insult anybody's intelligence. I just show you how a very clean and a very simple piece of code can go south really quick. And I believe that's what may happen to a real code on a much larger scale, large enough to turn refactoring into nightmare. Some people may disagree with me and be wrong. Oh well, this is my show, I have the mic, and I'm talking from my own experience discussing topics I'm passionate about. So please bear with me. Now, here's FizzBuzz. It is so simple that I won't even try explaining how it works. These are examples in Python and C#. In my blog post, I went into some crazy discussion using Python, so here I will do a similar thing in C#. You can find a link to my blog post in the description below. Let me make a little disclaimer. Since my channel is called, read my lips, Crazy Algorithmics, I promise I will stretch some of the concepts outside of the reasonable boundaries. They may even look ridiculous. What I'm trying to accomplish is to show how obviously simple things can get out of control in the real world. In FizzBuzz, as I'm sure you know, we have to create a function which takes an integer as an input and returns a string. In case the integer is divisible by 3, return fizz, by 5, return buzz, and if divisible by both, return FizzBuzz, blah blah blah. Very easy. Right now, some people may mistakenly think that they would never encounter FizzBuzz in their real-life application. Let me prove them wrong. Let's rename this FizzBuzz into, say, calculate discount. That's a good name. With more official name, our little function gets higher responsibilities. It will be calculating discounts based on some criteria. And to begin with, we will only offer discount on the days of each month, divisible by 3, which is package number 3 in our discount algorithm. Days divisible by 5, which is package number 5, or a special discount in the middle and the end of the month. That is number 15, of course. Hey, who would have thought that our innocent FizzBuzz can come really handy in the retail industry? Our function will still return fizz, buzz, and FizzBuzz, but in a real-life application it would call some other functions or trigger calculations. We'll talk about it some other time. As soon as we deploy the software, our glorious FizzBuzz, calculate discount algorithm, into production, the management comes to you and says, we need to add a lucky 7 discount. In the context of our algorithm, it means adding another division check. Since doing that is very simple, we will be happy to open our code and add a couple of lines, completely destroying open-close principle, the foundation of object-oriented programming. But it works, and we're happy to give users a lucky 7 discount. They must be very happy. The management is happy too, but now they think it's a good time to restructure the system of discounts. Oh. First, we need to offer lucky 7 discount package only if the day divisible by 7 is Sunday. I don't want to use a system date here to figure out the day of the week. What if the customer got a rain check and comes back 3 days later, but they're still eligible for a lucky 7 discount? Besides, being an advocate of functional approach in programming, I prefer passing all necessary arguments from outside. That means we need another parameter, which is day of the week. And that means we have to modify the signature of the method. I know some of you may be screaming right now, no, just create an overload with a different method signature. Yes, I know, but remember, not all languages allow that. Okay, I modified the code to check the day of the week. I use a list here because there may be more than one day we want to make the algorithm active. Here's the code in C# and Python again. While in C# we can add method overload and keep open-close principles somewhat valid, in Python we don't have this option. We would have to create an optional parameter. Well, just as you thought everything worked out well, you receive new requirements. Management just came up with a new exciting discount program. That's wonderful. We love our loyal customers. And here's what we have coming. Mid-month program number 15 of FizzBuzz in our original algorithm should only happen on Saturdays and Sundays. When 15th is Friday, then it should be handled by program number 5, which is original buzz. On Monday through Thursday, the program 15 should be handled by Fizz, or program number 3. Lucky 7 should only be applied on Sundays. However, in case the customer is eligible for special exciting discount program 105, which is 3 times 5 times 7 by the way, then FizzBuzz number 15 should take a precedence. I don't know where 105 came from. That's not a day of the month, obviously. Perhaps the management decided to count days of the year instead. Whatever, who cares? And the rest of operations are as usual. As you can see, even such a mess can be written in some clean code. but this is just the beginning. I haven't implemented program 105 here. I will leave it for you as a home assignment if you want to play with it. But I think I've created enough mess already so we can talk about some concepts and develop a strategy to solve the potential problem. Yes, pun intended, because strategy is the name of object-oriented design pattern. First, let's clarify some of the requirements. Remember, we're still FizzBuzzing. That means program fizz will be activated by any number divisible by 3, buzz by any divisible by 5. Just as we said in the very beginning, Lucky 7 will be activated by any number divisible by 7. And 105, our special discount program, which is divisible by 3, 5, and 7, and of course 15. I will leave it for you. So we need to follow the instructions regarding priorities of each choice depending on the day of the week. Like I said before, that's kind of a silly example, but it will set the stage for some crazy programming. Keep in mind, this is all about what can be done, not necessarily what it should and how it should be done in every case. Crazy experimental coding, so to speak. When I mentioned strategy pattern, the first thing that comes to mind is to split this ugly if logic into separate objects. From here on, I will only work with C# in this video. If you prefer Python example, I have them in my blog post. Somewhat similar but different because Python is different from C#, obviously. Again, the link is in the description. Now, there is a challenge with this approach. No, the problem is not polymorphism. C# handles it well. Look at this if block. It is doing two things now, checking if the number is divisible by all these numbers and also setting the order in which we need to check. And if I take this logic out and put it into separate objects, then how would I know which object to call and in which sequence? I've used system reflection before to instantiate object based off of the property of the caller, but in our case, the property of the caller, meaning divisibility by one of the prime numbers, is being calculated by the outside algorithm I need to call. That's like locking myself out of the code. Crazy, isn't it? I guess point proven. Let's keep going. So here's the architecture I have in mind. Let's pretend that our original FizzBuzz or calculate discount is the main calling class, even though it is rather small and it only has this if logic I want to take out. The logic will go into outside classes. All it is doing now, of course, is checking divisibility of the number and returning the corresponding string. In reality, it should do something more significant, of course. Finally, the sequence in which it will call these objects will be defined in another object. Let's call it rules, which is actually the name of another design pattern. The rules will hold a collection of, well, rules, of course, in a sequence. Once we call this rules object, it will check each rule and execute the first one meeting the criteria. All this is done to take ugly conditional logic out of the code and to make our application easy to extend or modify. That means we won't need to make any more changes to the main code. All we have to do is to add another rule. Let's do it. But first, let's look at the existing code. Each condition check is a rule. We can take them out and create separate classes, but like I said before, this long, ugly if block was also constructed in a certain sequence. If you change it, the algorithm won't work. I can preserve this sequence in my rules class, but let's take little steps. The way rules pattern works, each rule has to be a separate class. It should hold the knowledge about its own applicability in each case, and it should not hold any knowledge whatsoever about other rules. Rules Manager class will iterate over the list of available rules and ask each one, these are the values I have. Are you the one to handle them? If yes, the rule will execute some code. If not, check another one. Each rule does not even know if there are any other rules. This wonderful approach helps us to totally decouple the code. We can add or remove rules as we need without modifying and, what's more important, without breaking any other code. I will create an interface for my rules object. I could have used abstract class, but I don't expect any common logic in my humble application. Just a side note, some languages like Python, for example, don't have interfaces, but you can still use abstract-based class. My rule object will only have two methods, isApplicable and FizzBuzz. Yes, let's not forget where it came from and pay a little respect to the roots. The ruler of the rules, the object I call rules, will hold the collection of rules and look for the first item which meets the criteria. First default, as you most likely know, will return the first valid item or a null. Therefore, I use a single question mark indicating that this can be a null to avoid exception, since I'm calling a method FizzBuzz. Now, if first default is null, then the whole expression is null, and null coalescing operator will return the default value, which is no luck today. It only has one rule now, which is divisible by 3, and the rule object itself is rather simple. It is checking the condition which used to be part of the if logic and returning a string. Now, let's implement the remaining rules. As you can see, each rule has condition checking and it returns the result. So keep in mind, conditional if operators are still valid. We have to check the values, but the logic flow is based on object interaction rather than hard-coded if statement. Each rule is only responsible for itself. I can replace them at any time, delete or add new rules if necessary, and my rules manager will simply hold the collection of those rule objects. It doesn't even know what concrete class comes through the interface, and it doesn't care. Well, other than being a totally bizarre application, I think it came out fairly decent, except a couple of things I will address next. First, let's take a look at this beautiful rules class. There is a statement in object-oriented programming, new is glue. Ouch! Right now I have 6 classes I'm instantiating. That means every time I add or remove a rule, I have to update this class. That shouldn't happen. Second, take a look at these 2 rules. If rule 3 or 5 come before rule 15, either one will act like a default rule taking on the responsibility. That's why I added rules in Rules Manager in that exact sequence, like they were in my original if block. This can actually create a major bug in the system, and that's not good. I think the best way would be to specify each rule, what conditions for which rules are valid and when they are not, like I did in this rule number 15, specifying that days are not Friday, Saturday, or Sunday. I won't do it here. If you like, you can play with that on your own. Just make sure to create plenty of unit tests for each rule. The other issue I want to address is loading sequence from outside config file. Let me do something crazy, since the channel is called Crazy Algorithmics anyway. I will be using system reflection to instantiate those objects. Here's a couple of ways for you can think about and to experiment with. Perhaps the simplest one I used was storing a list of rules in a database. There you can also specify the sequence number and sort them by using that field. That's in case if specifying every rejecting condition becomes too complex. So here's an example. I created a class outside rules that I will use to mock a return from a database call. All it does is returns a list of strings, the list of names for our rules. I also modified Rules Manager class, and instead of adding classes to the list manually like I did first, I will use Activator to create a list of rules out of list of names. Perhaps not the best solution. You're welcome to modify it or create your own if you like. You may also want to add some exception handling here. The idea is, if done correctly, this Rules Manager will never have to be modified. That's cool. I could have stopped here, but I'd like to add a little cherry of insanity on the top of my cake of craziness. You see, every time I want to add another rule, I would have to add a new name to the database or to the outside file where I store those names. Eventually, this may become annoying depending how often we have to do that. Here's a quick way you can do it, which may or may not work for every scenario. I created another class which is searching my entire application for names of classes that implement iRule interface. All I have to do is to make sure my rule implements iRule. That's it. Do you see how much easier this becomes? Everything else will be the same. The code returns a list of names just like the other class. Keep in mind though that up until now I specified the sequence in which my application will call these rules. Using this search may not be as predictable. One cheap way to address this issue can be naming classes, let's say using numbers as a part of the name, like rule 001, 15 weekend, rule 002, 15 weekdays, etc. Of course, that's only necessary in cases like FizzBuzz where the sequence matters. Then simply sorting the resulting list by name will do the job. I actually use exactly this approach when I take screenshots for my courses. Then I don't have to worry about sequence. They are sorted by name. This is just a thought. Remember, if you use this last method, your application will scoop all of the classes of specific interface and it will run them through the loop without even asking their name. Nobody needs the name. Just tell me, can you do the job for these values? Isn't that cool? I think it is. And I also think there should be enough craziness for today. Not all of my episodes will be that crazy. Some of them will actually be much worse. Just kidding, relax. But thanks for watching. If you like it, give me a thumbs up, like this video, and I will talk to you next time.